Smoothbore muskets, 17th century to mid-19th century. Before the military rifle, there was the smoothbore musket. Weapons like the British Brown Bess and the French Charleville musket dominated European battlefields for over a century. These firearms used a smooth barrel and fired a round lead ball. Accuracy was limited. Effective range was often under 100 meters. These muskets used flintlock ignition, later replaced by percussion caps in the early 19th century. Despite improvements in reliability, the fundamental limitation remained. Smoothbores could not stabilize a projectile in flight. The solution was rifling. Rifled muskets, 1850s to 1860s. Rifling spiral grooves cut inside the barrel had existed for centuries but was difficult to use in military muskets because tight-fitting bullets slowed loading. That changed with the invention of the Minié ball in the 1840s. This conical projectile expanded upon firing, gripping the rifling without requiring tight manual loading. Rifled muskets like the Springfield Model 1861 and the Enfield Pattern 1853 drastically increased effective range, from under 100 meters to 300 to 500 meters. Despite improved range, these weapons were still muzzle-loaded and slow to reload. The next breakthrough addressed that limitation: breech-loading rifles. In the mid-19th century, military rifles transitioned from loading at the muzzle to loading at the breech, the rear of the barrel. The Dries needle gun, adopted by Prussia in 1841, was one of the first successful military breech loaders. It used a paper cartridge and a bolt mechanism that allowed soldiers to reload while lying prone, a major tactical advantage. France responded with the Chassepot rifle, which improved sealing and velocity. However, paper cartridges were vulnerable to moisture and gas leakage. The final step was metallic cartridges. Metallic cartridge rifles, 1860s to 1880s. The development of self-contained metallic cartridges solved multiple problems at once. Each cartridge contained primer, powder, and bullet in a sealed brass casing. This improved reliability, resistance to weather, and chamber sealing. Rifles like the Martini-Henry, British Empire, and early Mauser bolt-action rifles adopted metallic cartridges and strong locking mechanisms. By the late 19th century, the modern rifle platform was taking shape. Bolt-action military rifles, 1880s to 1900. The bolt-action rifle became the standard military rifle by the end of the 19th century. Key examples include Mauser Gewehr, 98, Germany; Lee Enfield, Britain; Mosin Nagant, Russia; Springfield 1903, United States. These rifles shared core features: rotating bolt with locking lugs, internal magazine, typically 5 rounds, stripper clip loading, high-velocity smokeless cartridges. The Mauser 98, introduced in 1898, became one of the most influential rifle designs ever made. Its controlled feed bolt system and strong action were copied or licensed worldwide. The British Lee Enfield emphasized faster cycling and higher sustained rate of fire. Russian forces adopted the rugged Mosin Nagant, designed for simplicity and mass production. Bolt-action rifles were durable, accurate, and reliable. For over half a century, they would dominate global battlefields. End of the 19th century. By 1900, the military rifle had evolved from smoothbore, inaccurate volley weapons, to high-velocity, magazine-fed precision tools. Key advancements included rifled barrels, metallic cartridges, smokeless powder, bolt-action mechanisms. The infantryman was no longer limited to short-range volleys. He carried a weapon capable of hundreds of meters of effective fire. But industrial warfare was about to demand something even faster: the World War I infantry rifle. At the start of the 20th century, nearly every major military entered World War I armed with bolt-action rifles, firing full-power cartridges. Examples included Gewehr 98, Germany; Lee Enfield SMLE, Britain; Mosin Nagant M 1891, Russia; Springfield 1903, United States; Lebel 1886, France. These rifles fired high-velocity rounds capable of effective fire beyond 600 meters. Accuracy and penetration were emphasized, reflecting pre-war doctrine that expected long-range engagements. However, trench warfare changed how rifles were used. Engagement distances collapsed. Mud, debris, and confined spaces limited maneuverability. Despite this, bolt-action rifles remained reliable under harsh conditions. The British Lee Enfield stood out for its rapid rate of fire. Trained soldiers could fire 15 to 20 aimed shots per minute, compensating for the lack of automatic capability. The limits of bolt-action doctrine. World War I revealed a critical issue. Bolt-action rifles were accurate but slow for close-quarters combat. As battles became increasingly static and infantry assaults relied on suppressive fire, armies turned to machine guns, light machine guns, submachine guns, Rifles were no longer the primary source of volume fire. This exposed a gap between long-range precision weapons and short-range automatic arms. Military planners began exploring self-loading rifles to increase infantry firepower without abandoning accuracy. Early semi-automatic experiments. Between the wars, several nations experimented with semi-automatic infantry rifles. Notable examples: Mondragon Rifle, Mexico; SVT-38 and SVT-40, Soviet Union; MAS-40 prototypes, France. These rifles used gas-operated or recoil-operated systems to automatically cycle the action after each shot. Early designs faced problems: complex mechanisms, sensitivity to dirt, higher production costs, increased maintenance requirements. As a result, most armies retained bolt-action rifles while refining semi-auto concepts. World War II, bolt-action versus semi-automatic. World War II marked the first large-scale conflict where semi-automatic rifles were issued alongside bolt-actions. The breakthrough, M1 Garand. The M1 Garand, adopted by the United States in 1936, was the first standard-issue semi-automatic rifle used by a major power. Key features: gas-operated system, 8-round en-bloc clip, 30-06 cartridge, semi-automatic fire with every trigger pull. Compared to bolt-action rifles, the Garand allowed American infantry to deliver significantly higher sustained firepower without sacrificing accuracy. General George S. Patton famously called it the greatest battle implement ever devised. The birth of the assault rifle concept, STG-44. While semi-automatic rifles increased fire rate, another revolutionary idea emerged in Germany. The Sturmgewehr 44 combined three key elements: select fire capability, intermediate cartridge, 7.92 by 33 mm Kurz, detachable magazine. Combat data showed that most infantry engagements occurred within 300 meters. Full-power rifle cartridges were unnecessary for this range and produced excessive recoil in automatic fire. The STG-44 offered controllable automatic fire and sufficient range for typical combat distances. It was the first true assault rifle, and it fundamentally changed infantry doctrine. Early Cold War rifles. After World War II, many militaries hesitated to fully embrace intermediate cartridges. Instead, they adopted battle rifles firing full-power cartridges, often in semi-automatic or selective fire configurations. Examples: FNF-AL 7.62 by 51 NATO, G3 7.62 by 51 NATO, M14 United States, SKS Soviet Union transitional design. These rifles emphasized long-range capability and interoperability, but suffered from heavy recoil in automatic fire. The battle rifle represented a compromise between traditional doctrine and emerging assault rifle concepts. By the early 1950s, military rifle development stood at a crossroads. Two philosophies competed: full-power, long-range battle rifles, intermediate cartridge, controllable assault rifles. World War II proved that infantry firepower mattered as much as accuracy, and that the individual rifleman needed faster, more flexible weapons. The final shift would come with the global adoption of true assault rifles. The AK-47. In 1947, the Soviet Union adopted the AK-47, marking the beginning of the modern assault rifle era. Chambered in 7.62 by 39 mm, the AK combined an intermediate cartridge, select fire capability, a detachable magazine, a long-stroke gas piston system. The design prioritized reliability and ease of manufacture over precision. Loose tolerances allowed the rifle to function in dirt, sand, and extreme weather. The AK proved that a simple, robust assault rifle could arm millions of soldiers effectively. The M16. The United States took a different approach. The M16, adopted in the 1960s, was lighter, fired the 5.56 by 45 mm NATO cartridge, and used a direct gas impingement system. Key advantages included reduced recoil, higher velocity, lighter ammunition, allowing soldiers to carry more rounds. Early adoption in Vietnam was plagued by issues: incorrect powder, lack of chrome-lined barrels, inadequate training. Once corrected, the M16 platform matured into a reliable and accurate service rifle. Its modular design allowed for continuous upgrades, leading to the M4 carbine. The M16 established the concept of a lightweight, high-velocity assault rifle optimized for modern infantry combat. NATO standardization and the 5.56 era. During the Cold War, NATO standardized the 5.56 by 45 mm cartridge. This decision reflected battlefield realities. Most engagements occurred under 300 meters. Controllable automatic fire mattered more than raw power. Logistics favored lighter ammunition. Many NATO countries adopted or developed rifles around this cartridge: FNC, L85, G36, C7, SIG 550. Standardization improved interoperability between allied forces and simplified supply chains. Bullpup designs. Some militaries sought compact rifles without sacrificing barrel length, leading to bullpup designs where the action and magazine sit behind the trigger. Notable examples: Steyr AUG, famous L85, Taver. Bullpups offered short overall length, full-length barrels, improved maneuverability in vehicles and urban environments. However, drawbacks included poor ergonomics for left-handed shooters, complex trigger linkages, difficult maintenance. Bullpups remain popular with some militaries but are not universally adopted. The modular rifle era, 2000s to 2010s. By the early 2000s, infantry rifles became platforms rather than fixed designs. Key characteristics: Picatinny rails, optical sights as standard, vertical grips and accessories, adjustable stocks. Rifles such as the HK416, FN SCAR, and SIG SG516 improved reliability while maintaining modularity. Optics replaced iron sights as primary aiming systems, increasing hit probability at all ranges. Suppressors, once niche equipment, became common due to improved communication and night operations. Modern Russian and Chinese developments. Russia updated the AK platform with rifles like the AK-74, AK-12, and modernized optics integration. China developed the QBZ-95 and later QBZ-191, reflecting a move away from bullpup designs toward more conventional layouts. These rifles emphasized modern ergonomics, optics compatibility, and improved manufacturing. Next-generation rifles, 2015 to 2025. Recent conflicts have highlighted limitations of 5.56mm rounds against modern body armor. In response, new programs emerged: US NGSW program, adoption of 6.8mm cartridges, suppressor-first doctrine, advanced fire control optics. Rifles like the SIG MCX Spear represent a shift toward higher pressure cartridges, improved terminal performance, integrated electronics. This marks the beginning of the post-5.56 era, though widespread adoption is still ongoing. Over 3 centuries, the military rifle evolved through ignition systems, cartridge development, action mechanisms, fire control philosophy, modularity and digital integration. From smoothbore muskets to electronically enhanced assault rifles, the military rifle reflects how warfare itself has changed. Despite constant innovation, one principle remains unchanged. The infantry rifle exists to give the individual soldier effective firepower at realistic combat distances.